Good day, everyone. Today we are going to be talking about Introduction to Analysis of Variance or ANOVA.
What is analysis of variance or ANOVA? ANOVA is a statistical method used to compare the means of two or more groups. What is the importance of ANOVA? ANOVA is helpful for testing three or more variables. It is similar to multiple two-sample t-tests. However, it results in fewer type 1 errors and is appropriate for a range of issues. ANOVA groups differences by comparing the means of each group and includes spreading out the variance into diverse sources. The, analysis, the analysis of variance, or ANOVA, has been recognized as the most common statistical procedure used in psychological research, and its main goal is to determine how much the groups in an experiment differ for purposes of statistical significance.
Next, we have the analysis of variance. First, we have factors, which also means variables. Then we have the levels. Factors are the general part of something. For example, subjects. Subjects is a factor because there are a lot of examples under subjects. Then we have levels, which are the more specific ones like economics, medicine, and history. These examples are under subjects. Then we have the different types of ANOVA. First, we have one-way ANOVA, or is one factor with at least two levels are independent. And we also have repeated measures ANOVA. One factor with at least two levels. Levels are dependent. And to know the difference between independent and dependent variables is that independent variables are the variables to be manipulated and the dependent variables are the variables to be measured. As you look at the table, each subject has scores and those scores are the ones to be measured, making it a dependent variable. Next we have factorial ANOVA. Two or more factors, each of which with at least two levels. Levels can either be independent, dependent, or both. So here is an example with at least two levels, which are the students, and the other we have MGS. So those are the two factors. Now let's have assumptions in ANOVA. First, normality of sampling distribution of means. The distribution of sample means is normally distributed. Second, the independence of errors. Errors between cases are independent of one another. Third, absence of outliers. Outlying scores have been removed from the dataset. And last, homogeneity of variance. Population variances in different levels of each independent variables are equal. Now we have hypothesis in ANOVA. Imagine you have one factor with three levels. Your null hypothesis is that all three levels are equal to one another. Your alternative is that not all means are equal. When you're dealing with the effects of one variable, it's called the main effect. But here, imagine we have an ANOVA with two factors, A and B. You would have three different sets of hypotheses. You would have one for A and one for B and one for the combination. So here we have the main effects of A and the main effects of B. You can also test for the interaction of A and B, which would be structured just like that, the null being the interaction is absent, and the alternative being that the interaction is present. Then there's the main effects in ANOVA. A main effect, also called a simple effect, is the effect of one independent variable on the dependent variable. It ignores the effects of any other independent variable. In general, there is one main effect for each dependent variable. Pretend we're comparing the test scores of people who have received the medication 100 mg dosage group and people who have not received the medication 0 mg dosage group. The 0 mg condition has a mean of 40, while the 100 mg condition has a mean of 90. This could be presented in a graph like this. Then we have interaction effects in ANOVA. Interaction effects occur when the effects of one variable depends on the value of another variable. Here we have ANOVA with two factors, dosage 0 mg and 100 mg, and gender, men and women. In the 0 mg dosage condition, men have a mean of 60 while women have a mean of 90. In the 100 mg dosage condition, men have a mean of 90 while women have a mean of 50. This could be represented in a graph like this. You can see that the line of men and women will cross. If the line crosses like this, then that means you have an interaction effects in your ANOVA. After you do the ANOVA, you might do something called post-hoc analysis. Post-hoc tests are designed for situations in which the researchers has already obtained a significant omnibus F test with a factor that consists of 3 or more means, and additional exploration of the differences among means is needed to provide specific information on which means are significantly different from each other. If we reject the null hypothesis, all we know is that there is a difference somewhere among the groups. Additional tests called post-hoc tests can be done to determine where differences lie. And of course, we have the F distribution. An F statistic is a value you get when you run an ANOVA test to find out if the means between two populations are significantly different. When doing an ANOVA, we'll calculate an F statistic. It is similar to other statistics such as Z and T. F is at its most basic form like this. It is treatment differences plus random differences divided by random differences. If there are no treatment differences, that is, if there is no actual effect, we expect F to be 1. If there are treatment differences, we expect F to be greater than 1. The F statistics has its own one-tailed distribution, much like how the Z and T statistics have their own separate distribution. It is always one-tailed and the F is always positive. If you get a negative F, it means you made some kind of mistake. Now that we're done introducing you to ANOVA, let's then now go to ANOVA computations. What to use in solving ANOVA? First, you need writing materials and paper. Then you need a scientific calculator and the latest models the most preferable. You also need the critical values of the F distribution 1 and 5% level of significance. Aside from those materials, you need to know the steps in solving ANOVA. The first step is to state the null hypothesis. And this is how the null hypothesis must look like. The second step is to set the alpha. If the given alpha is 1%, you will also use the 1% level of significance. If the given alpha is 5%, you will also use the 5% level of significance. The third step is to accomplish the ANOVA table. And this is the ANOVA table, where we have source of variation, sum of squares, df, mean of squares, and the f. These are the formulas under the sum of squares, where A is the given factor or the category, I is the individual observations of cell, N is the sample size, K the number of columns, and X are the observed values. The fourth step is to find the tabular value. The last step, decide. Now, let's start. Now, the first example we have, determine who among the three salesmen will likely be promoted based on their monthly sales in pesos. Use a 5% alpha. If you look at the table, we have three columns, column A, B, and C. First thing you need to do is to find the squares of each variable. And then here we have the squares of each variable. The next thing to do is to find the summations of each column. So the first one is the summation of A, which is 1,300, B is 1,291, and C 1,285. Then we have the A squared, which is 195,122, and then the B squared we have 189,243, and then the C squared we have 185,613. After finding the summations, you then have to state the null hypothesis. And our null hypothesis is that there is no significant difference among the three salesmen. After stating the hypothesis, you then have to set the alpha. And our alpha is 5%. The third step is to accomplish the ANOVA table. And here we have the ANOVA table. And under it is the source of variation, sum of squares, df, mean of squares, and the f. First we have the SSP. This is the longer formula, and if you're wondering why it's 27, why n is 27, it is because we have 3 columns and 9 rows, and to get 27 you have to multiply it. So 3 times 9 is equal to 27. That's how you get the n. After that, you have to substitute each and every one. You have to do it carefully and properly. And then we get the answer of 12.67. Then there's the TSS. Same thing with the formula, and then substitute it well again properly. You must not make mistakes, because if you have one mistake in this, it's all wrong. Then you get the answer of 13,556.67. Then we have the SSW. You just have to substitute it, and then you get the answer of 13,544. Now let's look at our ANOVA table and put our answers under the sum of square of between, which is 12.67, within 13,544, and total is 13,556.67. Let's now go to DF. Under DFB, which is K minus 1, and then K is 3 because, as we all know, we have 3 columns and K will always be based on the column. So 3 minus 1 is equals to 2. And then let's go to DFW. 27 minus 3 equals to 24. And then our DFT, 27 minus 1 is equals to 26. Now let's go to MSB. Just have to substitute it, and then you get the answer of 6.34. Now let's start with MSW. Again, just substitute it and then you get the answer of 564.33. Then we have the F. Just substitute it and then you get the answer of 0.01. Now I have 2 and 24 there for because 2 we have 2 columns and 24 because we have 24 rows. Let's now look for our tabular value. We have column 2 and row 24. Now let's look at column 2 and row 24. We have 3.40 because it's the intersection of the column and row. Now let's decide. We have the TV of 3.40 and the CV of 0.01. Let's compare both of them and apply the HRLA. Since TV is higher, the decision is that the HO is accepted because the CV is lower than the TV, and there is no significant difference among the three salesmen. Now that we're done with the first activity, let's then now go to the second one. Since I explained the first activity to you in detail, I'm just going to guide you in this activity. The second activity is determine which among the three departments holds more behaved students based on their ratings or performances. Use the 5% alpha. On the table we have three columns, column A, Montessori, column B, daycare, and column C, preschool. Again, the first thing we need to do is to square each variable. And here we have the answers of each variable. After squaring the variables, you have to find the summation of each column, which is column A, summation is 56, B, 38, C, 29, A squared, 458, B squared, 212, and C squared, 131. And our null hypothesis is that there is no significant difference among the three departments. Set the alpha, which is 5%. Now let's complete our ANOVA table. First, we'll start with SSB. The thing you need to do is substitute, as I said earlier in this video. Then we get the answer of 54. Now let's have the TSS. Just substitute it accurately and then you get the answer of 80.57. Then we have the SSW. Just substitute it again and then you get the answer of 26.57. Now we have the answers under sum of squares, where in between we have 54 within 26.57 and total of 80.57. Now let's go to DF. So let's start with DFB. We have 3 minus 1 is equals to 2. And then DFW we have 21 minus 3 and then we get the answer of 18. And then the DFT we have 21 minus 1 and then you get the answer of 20. Now let's have the MSB. You have to substitute it and then you get the answer of 27. Now let's have the MSW. You just have to substitute the right numbers and then you get the answer of 1.48. Now let's have the F. Just substitute the right numbers accurately and then you get the answer of 18.24. And we have the column of 2 and the row of 18. Now let's look at our tabular value and look at column 2 and row 18. And then you get the answer of 3.55. Now let's make our decision. We have the TV of 3.55, the CV of 18.24. Now let's compare both of them and apply the HRLA. Since CV is greater, we have the decision of The HO is rejected because CV is higher than the TV, and there is a significant difference among the three departments. Now that we're done with the second activity, let's now go to the third and the last activity. Here we have the third example, which is to determine who will be granted the scholarship based on academic performances and kind of schools attended. Use the 5% alpha. On the table, we have the list of schools, and the first thing we need to do is to square each and every variable. And here we have the squares of each variable. The next thing we need to do is to find the summation of each. Here we have A for 61.5, A squared 540.55, B 61.3, B squared 537.97, C 60.7, C squared 528.77, and D 60.8, and D squared 531.54. Now we have the HO of there is no significant difference between academic performance and kind of school attended. Now we have the alpha of 5%. Now let's complete our ANOVA table. Let's start with SSB. Substitute the accurate numbers and then you get the answer of 0.06. Now let's go with TSS. Just substitute the accurate numbers again and then you get the answer of 7.31. Then we have the SSW. Just substitute the right numbers and then you get the answer of 7.25. Here we have the answers and the sum of squares where between is 0.06, within is 7.25, and total of 7.31. Now let's go to DF and start with DFP. We have 4 minus 1, we get the answer of 3. And then DFW, we have 28 minus 4, and then you get 24. And then DFT, we have 28 minus 1, and then you get the answer of 27. Now let's have the MSB. Substitute the right numbers, and then you get the answer of 0.02. Then we have the MSW. Just substitute the right numbers, and then you get the answer of 0.30. Then we have the F. Again, just substitute it, and then you get the answer of 0.07. And then we have 3 columns and 24 rows. Let's take a look at our tabular value. On column 3 and on row 24, the intersection point is at 3.01. Then let's make our decision. We have the TV of 3.01, the TV of 0.07. Let's compare both numbers and apply the HRLA. And then we have finally had the decision that the HO is accepted because the CV is lower than the TV, and there is no significant difference among the three departments. Well, that ends our video. I hope you understand ANOVA better, and that's all. Thank you.